Good day, Leon here. I've been wanting to make a video like this for quite a long time because data grids are such an essential part of most user interfaces. They help users to view and interact with data in a structured table format. Think about rows of data and columns of data. In this video, I'll explore how low-code application development platforms make it easy for developers to create data grids in applications. I'll use two of the leading low-code platforms, namely Mendix and OutSystems, to demonstrate how pre-built widgets are used to quickly create data grids for your user interface. But before we start, let's just quickly define what is low-code. The most simplest definition is low-code is a way to build software faster with less coding. Instead of writing long lines of code, developers use visual tools. These are drag and drop tools where you place widgets on your canvas and you configure those widgets to create your applications. This makes application development also more accessible for people who don't come from a traditional programming or coding background. So I thought a great way to explain how low-code works is to compare it with high code or traditional coding, and then by creating a common UI component like a data grid by using both approaches. That's high code and low code, and we'll compare how the two low code platforms approaches this task. Okay, so what am I going to cover in this video? Firstly, I'm going to define what a data grid is in software terms. Then I'll explain the difference between high code and low code with some practical examples. Then I'll do a demo of how Mendix and OutSystems provide visual tools to construct data grids on screens. Lastly, I'll summarize by comparing how Mendix and OutSystems do data grids. Okay, let's have a look at a simple definition of what a data grid is. So a data grid is a user interface component commonly used in software applications to display tabular data in a structured row and column format. Actions that you can normally do on a data grid is to view your data, sort data, filter for specific data, and edit data. Other features might include pagination, column resizing, and inline editing. Next, I'm going to make a side-by-side comparison between high code and low code. Starting off with high code, to make a software application's UI available in a browser, a traditional developer needs to build and connect a bunch of technical components, and I'll quickly try to run through these. Let's keep it simple. Firstly, the front end, that's what users see and interact with in the browser. It normally consists of HTML, styling, and JavaScript. Then second component is the backend. So this is the engine room consisting out of a web server, application logic, the database that stores and retrieves your data, the API layer that connects front end and back end, and other components like authentication, authorization, and any app specific business logic. The third component is infrastructure, and your app needs to live somewhere. So you've got to deploy it to infrastructure either on a server in your own data center or on a cloud platform. Then you also have to configure your domain name and DNS, so users need a URL to reach your app, and you've got to make this secure by setting up HTTPS. This encrypts data between your browser and the server. And then there's other components like load balancer, perhaps, and also middleware connectivity. So you can see that there's significant effort and knowledge as well as experience required to create a full stack, that is the front end, the back end, as well as the glue in between, to build a simple app from scratch. And often you would find different people on the team that have got experience either in the front end or the back end or in databases or infrastructure. So it's very hard for one person to configure and set up all those components. And also for ongoing development and maintenance, you often need to configure and set up other tools like version control and build tools, CI/CD, login, monitoring. So it becomes quite complex scenario to do a traditional coded application. With low code, on the other hand, you have a platform, and most of what we've spoken about up to here, goes away for a developer. Um, a developer can immediately start to build an app. They can publish it and go and see their work in a browser in a matter of minutes. So the full stack is abstracted in a low-code platform, and it provides developers with visual tools to go and model their data. They can visually go and configure their logic. When it comes to the UI, there are a whole lot of pre-built widgets that you can drag and drop onto your screen in the IDE and go and configure that. And if you have business processes or workflow, you can also visually go and configure that. And then low-code platforms, especially like Mendix and OutSystems, have very good integration tools that you can easily connect to other applications in your ecosystem. And low-code platforms also come with built-in DevOps and maintenance tools, so you don't necessarily have to invest in a whole host of other tool sets. It's all provided for in one platform. Next, I'm just going to show examples of a high-code development environment as opposed to a low-code development environment. The code that I'm scrolling through on the left-hand side, that's front-end HTML and JavaScript code to present a data grid on a screen with some basic filtering and pagination. Data is hard-coded in this file. On the right-hand side, I've got the visual development environment of the Mendix platform open, and I'm looking at a table that I created earlier. If you click on a table, right click, there's an option to automatically generate initial UI for that table. So once it's done, you can go and view the screen for that, and you can see it created a data grid on the screen. Pretty much looks like what it'll look like in the browser. So you can run that app, so it basically generates everything that's needed for that app, and once it's done, you can go and view that app in the browser. So it's important to mention that the file on the left hand side on its own cannot run as an app. It needs all the other components that we spoke about earlier. Okay, now for the exciting part. Let's first see how Mendix creates data grids. Here's the screen that I created earlier. You can see there's a button added to add a new row. Each column is presented there, and you can resize the column. It also allows you to reorder the columns in that data grid. Each column also provides you the ability to sort, ascending, descending, and also to reset it. You can also add and remove columns, so each user can personalize the data grid. Each column has got a search field at the top as part of the column, so I'm just searching. You can see for the last name and first name, it created a unique list of first name and last names in the column. For email, you get the option to search for criteria like contains by, starts with, ends with, etc. So we'll just search for something that contains Johnson, and it'll list all the emails with Johnson in it. Same for phone number. Let's search for a phone that ends by 493, and it'll automatically return the filtered data. So you can also see you've got pagination. You can paginate through 20 records at a time, and you also have edit and delete icons at the end of the column. So that's the basic out of the box features. You can open the properties of your data grid in the IDE again. So that's the data source, and you can change how you want to select single row or multiple, and how you want that to display. I've selected checkbox now, and here are all the columns. You can add and add more columns if you need, and this is where you specify the page size that you paginate through, and the pagination buttons you can or the pagination yeah, you can put it above a grid or below or both at the top and the bottom. Yeah, so there's many other options that I won't run through now. You can also set permissions. You know, can a user sort? Can they resize the columns? Can they reorder the columns? And can they add and remove columns? So let's just use those configuration options for now. I'm going to run it again and then view it in the browser. Okay, now you can see on the left hand side there's checkboxes added, and I can select one or multiple. So the pagination is at the top and the bottom, automatically done for you, and you can select all fields or just clear that. Let's select a few other options. Let's choose virtual scrolling. You can also select load more, and a button will appear as you come to the bottom. You can just click and it will load more. So we'll just see how virtual scrolling works. So now as I scroll down on the right hand side, you can see the scroll bar. As it comes down to 20 records, it automatically loads another 20 records. So that just replaces your pagination buttons, which is a different way to do it, or you can just have a load more button at the end. Next, I'm going to demonstrate how to manually create a data grid on a screen. So in the IDE, I just create a new page, just add a blank page, and I just drag and drop a data grid widget or component on there, configure the properties, tie the data source to the data grid. It picks up all the columns from the table and automatically creates that data grid. So that's basically it. I'm just configuring the button to create a new row, and also the edit icon currently, and that's so you can see it generates quite a lot of things automatically, even if you do it manually. So all the filter fields are added at the top of each column for you. Okay, next let's see how OutSystems creates a data grid for you. So I've got the OutSystems IDE version 11 open here. I've also already created an app called the Grid app. Just open the front end module. And I've also created a table, a customer table with customer ID, first name, last name and email, and uploaded some data into that table. Then if I wanted to go and automatically create some UI, as I've done with Mendix, I'll just go to the main flow, go and look for my table, and you can drag and drop your table or your entity onto this screen, and it will automatically go and create a list screen and a detail screen. So let's quickly have a look at the detail screen that was created. So there you can see the data grid with the columns. I didn't quite add all the columns, so you can just drag and drop the phone number as well, and you can see it also added some pagination and a search field and a add customer button. So let's have a look at what other components it created. So it added some variables to store your search keyword. Start, index and max record, those are parameters that are needed for the pagination, and max record specifies what number is used for each page. Table sort is also a variable that is required to make sorting work in the grid. So the data source for the data grid is an aggregate, so it's just a visual query, and it pulled in the customer table. It added a basic filtering criteria on the first name, so if you search by first name, it will give you a filtered list, and you can add any of the other fields. Table sort also passes the column name that needs to be sorted. Then you've got an action that was created that needs to be triggered once you paginate. Then you've got a on search action, so if you enter any value in the search field, and then the on sort is also required when you click on that table header to either sort ascending or descending. Okay, so that's the very basic. So you can see there on the search field, when that changes, you can also see on the pagination widget, and on the table sort you'll also find the on sort action. So these are the basic components that are required for sorting, searching and pagination, and it creates that by automatically when you drag and drop your entity on the canvas. So I'm just publishing this app now, and we can go and see what it looks like in the browser. Okay, so here's your customer list with your search. So at this time it only searches on I think last name or first name. Let's quickly see. Yeah, it's only first name. You'll have to add all the other columns if you want to search by the other columns. It allows you to sort by column, and your pagination, it's 10 records at a time, so you can scroll through 10 records per page. And next I'm going to do this manually, and I'm just speeding up the video. So I drag and drop a new screen and drag a table or a DataGrid component or widget, tie it to the record, and I have to manually add some variables that I need to use, like the search, and then also for the pagination and sorting of table columns. I also have to add some criteria for the search, so for the search keyword. Yeah, and I have to manually add the search field and tie that to the search logic. Then I just dragged and dropped a pagination widget, so it's not really part of the DataGrid in OutSystems. It's a separate widget that you have to configure and create your own logic to make the pagination work. So I'm just creating the order by logic and publishing that, so that comes to almost about 6 minutes. To summarize, firstly I explained what a DataGrid is and what common features users normally can expect to have available in the UI. Then I talked about the complexity of building an app using traditional coding, and against that background I demonstrated how quick and easy it is to build an app using low-code platforms like Mendix and OutSystems. I demonstrated how these platforms can automate the generation of like a DataGrid screen, and how you can also build them from scratch using the standard widgets in the platform. I'll close with a few points to ponder. The first point is about productivity. A developer who uses a low-code platform does not have to worry about all the components of the stack that's required to run an app. Everything is provided for in the platform, and they can start to build the app on day one using visual tools instead of coding. Having said that, though, is with the advancement of artificial intelligence and specifically AI code generators, many tasks of the developer has become much more productive in recent years, but that also rings true for low-code platforms. So the next point is about capability of the DataGrid widgets in the two platforms, Mendix and OutSystems. So both platforms provides the ability to auto-create a DataGrid screen and provide basic features like column sorting and pagination. However, as you could see from the demonstration, the standard DataGrid widget provided by Mendix provides more capabilities out of the box than the OutSystems component. Mendix allows users to display or hide columns in the DataGrid. This is at runtime for the user. They can also drag and resize column sizes. It also provides filters within the column without having to necessarily write complicated filtering logic. And it also provides the ability to drag and drop columns to change the order of the columns in the grid. I have to mention though that there is an OutSystems Forge component available that can be downloaded and installed on your OutSystems environment. This is based on the open source Waymo JavaScript library, which provides advanced features similar to what Mendix provides. It is important to note, however, that this component is not available in the new ODC product. So if you plan to migrate in the near future, it may be wise to stick to the standard component for now. The last point is about speed. Both Mendix and OutSystems are leaders in the low-code app development space, and the demo that I did only gives you a tiny look into the power of low-code. What can be said is that low-code consistently outperforms traditional coding when it comes to speed. It was actually quite interesting to just time myself to see how long it took me to create the same task in both platforms. The questions I asked myself is how much effort is required, how quickly can I deliver the task, and what did I get in the end. So here is the result. So with Mendix it took half the time it took me to build the same task in OutSystems, and the Mendix DataGrid provided more features out of the box than OutSystems. So this holds true for many other comparable widgets where Mendix and OutSystems share a similar component. So it's important to it's an important point to ponder if you are in the process of choosing a low-code platform. But at the end of the day, both platforms can deliver similar outcomes. It is a matter of philosophy. So Mendix provide out-of-the-box widgets with many configuration options and built-in logic that is easy and quick to use. OutSystems provide similar out-of-the-box widgets with standard features, but it relies on developers to add logic and to use additional platform components as well as Forge components if they need to extend this with additional features. So in conclusion, in the future I believe traditional coding and low-code platforms will complement each other, shaping a hybrid development environment. Traditional coding will remain the backbone for complex, high-performance, intricate systems like AI models or low-level hardware integrations, etc. Low-code platforms, meanwhile, will dominate rapid, standardized app development, empowering developers, and that's coders as well as non-coders, to accelerate business solutions. Together they'll coexist, traditional coding for depth and customization, and low-code for speed and accessibility. So I hope you found this interesting and informative. Reach out to me if you wish to know more about low-code application development, or leave some comments for discussion. Thank you for taking the time to watch this video.